Have you ever been on a plane and just wondered about that invisible force that's flying millions of us across the globe every single day? Well, today we are pulling back the curtain on the autopilot. We're going to demystify how it works and get into the really deep questions it raises about our future with machines.
But let's start with a question that gets right to the heart of why these systems even exist in the first place. Do you actually need an autopilot to fly a plane? The short answer? Nope, not at all. You don't really need any instruments, to be honest. I mean, think about it. When the Wright brothers first took to the sky, they were flying completely by the seat of their pants, with not a single gauge or computer to help them out.
Okay, so if you don't need them to fly, then what's the big deal? Why have them? Well, it's not about the basic act of getting off the ground. It's about pushing past what a human pilot can do alone. You want to fly safely over long distances? You need instruments. You want to fly even farther without getting totally exhausted? Yeah, that's where the autopilot comes in. It's all about beating our own human limits.
And you know, the biggest limitation we have, it's just plain old fatigue. And we're not talking about physical effort here. A pilot isn't running a marathon in the cockpit. It's all about mental focus. Just imagine staring at instruments, tracking weather, checking flight paths for hours on end. It's exhausting. The brain, just like any muscle, gets tired. It needs a break. And that's exactly what the autopilot is for.
So, how in the world does an autopilot think? Well, to wrap your head around that, it actually helps to think about something we're all experts on, our own bodies. Because, as it turns out, pretty much every control system is built on the same basic ideas.
And I mean every single one, whether it's the simple thermostat in your house or the super complex guidance system on a rocket, it has four fundamental parts. First, you've got the plant. That's just the thing you're trying to control. Then you have sensors to get information, a controller to make the decisions, and finally, actuators to actually do the work.
And check out how perfectly this analogy fits together. The airplane itself is the body, right? The plant. The sensors that measure things like altitude and speed, well, those are its eyes, its ears, its sense of touch. The flight computer, that's the brain, the controller. And the actuators, the engines, the flaps, the things that move, those are the muscles. So, let's zoom in on what I think is the most fascinating part of this whole system. The sensors. How does a machine feel the world around it? I mean, how do you take something physical, like movement, and turn it into a digital signal that a computer can actually understand?
Well, it all comes down to this really simple but powerful difference. A sensor reads the physical world, things like pressure or motion, and turns it into an electrical signal. An actuator does the complete opposite. It takes an electrical signal from the computer and uses it to change the physical world, like moving a wing flap. They're really just two sides of the very same coin.
Now, one of the absolute most important sensors in this whole setup is the accelerometer. Its job is pretty straightforward. It measures acceleration. That's it, the rate of change of speed. It couldn't care less how fast you're going, only whether you're speeding up or slowing down.
And listen, this is a feeling we have all had. You're just sitting in a car, minding your own business, and the driver slams on the brakes. What happens? You lurch forward, right? That feeling? That's inertia. And an accelerometer is basically just a little device built to measure that exact force.
Okay, so the other key sensor here is the gyroscope. If the accelerometer handles moving in a straight line, the gyroscope handles turning. It measures what engineers call angular velocity. In other words, it tells the flight computer if the plane is pitching up or down, rolling from side to side, or yawing left and right.
And the physics behind this is the exact same thing that keeps you from tipping over when you're riding a bike. You know that stable feeling you get when the wheels are spinning? That's the gyroscopic effect. It creates stability and resists change. A gyroscope on a plane uses that very same principle to know its orientation in 3D space.
And here's the part that is just incredible. This technology, which used to be huge, mechanical, and super expensive, now fits on a tiny little chip that costs about $15. A chip that packs in 3 accelerometers and 3 gyroscopes. And yep, it's the exact same tech that's sitting in your phone right now, telling it which way is up. So, all this amazing technology brings us to a much bigger question. Is the autopilot just an assistant for the human pilot, or is it on its way to becoming a full-on replacement?
When you really break it down, each one has very different strengths. A machine? It's tireless. It can do the same systematic task perfectly, over and over for hours without ever needing a break. But a human, we have this unique ability to judge complex, totally new situations and make crucial decisions when everything goes sideways.
And this difference isn't just theoretical. It's literally written into aviation regulations. Autopilots are often flat-out prohibited from being used during takeoff and landing. And why is that? Because statistically, those are the most dangerous parts of any flight. The moments where the complex judgment of a human is still considered absolutely essential.
So it really comes down to this. Even with computers that can crunch millions of numbers of seconds, when things go truly horribly wrong, we still trust a human being at the controls. That ability to improvise, to think outside the box, that's something we just haven't figured out how to code yet.
Now, this whole debate is moving from 30,000 feet in the air right down to our city streets. As we develop more and more autonomous cars, we are being forced to face this incredibly difficult modern question. If an autonomous car gets into a fatal accident, who's responsible?
Seriously, who gets the blame? Is it the owner who turned on the feature? The government that said it was okay to use? The company that made one tiny faulty sensor? The programmer who wrote one bad line of code? The car company? There are just no easy answers, which leaves all of us with a final thought. As these systems get smarter and smarter, how much of our lives are we really willing to place in their hands?